Hey guys, here is a quick, helpful tutorial of your 1.16 intermediate value theorem problem. So we're just going to do some of them together. Okay, so the function f of x has a domain of -9 to 9, and it's plotted below such that the portion of the graph on the interval -4 to 3 is hidden from view. Given that f of -4 equals 6, and that f of 3 equals -2, determine what conclusions can be drawn based on the intermediate value theorem. So the only thing that makes me nervous about this problem is we don't have anywhere that their function is continuous on this domain. It just says it has a domain from -9 to 9, but that doesn't necessarily mean it's continuous. Like this could be a jump discontinuity and then continue, and that would still have a domain that's -9 to 9. So since it doesn't explicitly say it's continuous, I would say the function is not necessarily continuous, and therefore your intermediate value theorem cannot be applied. Therefore, there may not exist a value c in the interval -4 to 3 where my function has to be equal to -2. All right. Cool. All right, let's look at one. Okay, so this one, it does start off by saying it's continuous. So the function f of x is continuous on its domain from -9 to 9, and it's plotted such that this section is hidden. Given that f of -6 equals 2 and f of -1 equals -3, determine what conclusions can be drawn by the IVT on the interval -6 to 1. All right, so since the function is continuous on its domain, the intermediate value theorem can be applied. Oh goodness, okay. All right, and then it states for any value k in the interval, now remember my k's are my y values. My k's are my y values, so my y value. So on the interval from -3 to 2, there could exist a c value, and remember c's are my x's, so there could exist a c value, so a c value from -6 to -1, such that f of c equals k. Okay. Now it says, must there exist a value of c in the interval -6 to -1 where f of c equals -2? Well, let's look at our c and or our values that we came up with. So my graph at -6, it starts off at 2, and then at -1 it goes down to -3. And so since my function is continuous, do I have to hit -2 in order to get down there? My conclusion would be absolutely. You can't bypass -2 to get down to -3. Oops. So we would say there exists a value of c in your interval. So there's at some point between -6 and -1, there would have to be some place where f of c would be -2. And I love that they do a great job with explaining all of this information. So like they're showing you what your graph could have looked like in the section. So there's a way that you have to hit -2. They go into really in-depth detail about it. All right, let's do another one. Oops. The function f of x is continuous on its domain and is plotted such that the portion of the graph from -2 to 3 is hidden from view. Given that f of -2 equals 4 and f of 3 equals 2, we'll see if we can make some conclusions about it. All right, so first of all, it is continuous on its domain, so the intermediate value theorem can be applied. It states for any k in the interval, remember k are our y values, so for k values between 2 and 4, there could exist a value c between -2 and 3 that would give you that k value, right? So if I, now it wants us to ask about a certain k value. So must there exist a value of c in the interval where f of c equals 3? So let's see. If I start at -2 and I'm at 4, a value of 4, and then I have to somehow get to the y value of 2 by the time I get over here, do I have to pass 3 at some point to do that? The answer to that would be yes, because I have a continuous function. So no matter what happens in between here, like my graph could go up and then come back down and then go back up, at some point I would have to get all the way down to 2, which means I'd have to pass through the y value of 3. So there exists a value of c. So somewhere in this interval, there would be a place that when I plugged c into my function, I would have to get a y value of 3. Beautiful. All right, I want to see if there's like one more type of the problem. This one might just be a very similar one. It can't hurt to do another one. So the function f of x is continuous on the domain, and it's plotted this way. So from at -5, my graph starts at 3, and then by the time I get over to 0, my y values go up to 6. So I'll have to hit every value between 3 and 6 in order to do that. So it's continuous, so it can be applied. So any value k between, so whatever my value is, my range from 3 to 6, my y values, there has to be a c value between -5 and 0 such that f of c equals k. Does there have to be a place where my function equals 5? Well, you just have to check. Does 5 fall between 3 and 6? Absolutely. So there has to be some place on this graph that when you plug in that x value to your equation, you go up and you would get a y value of 5. Voila. All right, let me know if you have more questions.